Hi and welcome back. Today I'm going to start assembling the parts that I need to build 4 portable forges. I've been playing around with this idea for a while, and the first time that I actually had a chance to build it was last year when I needed to build the 5 forges that you see here. These are a rivet style forge where the bellows are contained in the framework for the forge itself. So that makes them portable, but unfortunately it limits the size that you can make the bellows. So that was a concern when I built these. Also, the bellows are foot operated, which simplifies the building a little bit and reduces the number of parts that I needed to put together. I won't be doing that again. I wasn't really happy with that part of it, but the bellows and the forge, they worked great, and I'll be basically just copying this idea with the new forges that I'm building. This is the kit that I'm starting with. It's 1/8 inch plate, and it was cut out on a CNC plasma cutter, so I had 4 of these made, and basically all I need to do is disconnect all the parts and assemble them. So it's a real time saver, which is great because I'm once again working on kind of a tight deadline with this job. So here are all the parts that I had cut out. The parts for the fire pot are here, as well as some additional pieces. This larger square is going to be the top flange of the fire pot. The 3 smaller squares, one of them is going to be the bottom of the fire pot, and the other 2 are just connector plates that are going to connect the fire pot to the tube leading to the bellows. The solid square piece is going to be the cap for the ash dump. And all of these parts are cut to fit around a 2-inch square tubing. This row of triangular pieces are gusset plates that I'm going to use to brace the angle iron frame that I'm bolting together for the forge. These 2 larger beveled plates are the sides of the fire pot, and at the far end of the table there are 2 more gusset plates, as well as some smaller tabs that are going to be used for hinges. For example, the ash dump needs a hinge, and it's going to be made from these parts. And these are just extra parts that I use to fill in the spaces on the plate. The only part that I didn't show you here was the larger plate that's going to be the forge basin, but I don't need to do anything to it, so I don't have it here in the shop. And then once you have all the pieces together, it's just a matter of welding everything in place. The air for the fire is supplied by a T-shaped pipe that gets mounted to the bottom side of the fire pot. The bottom end of the long vertical section gets capped off so it can collect any ashes that happen to fall through the grate that supports the fire. The pipe from the bellows gets connected here, and I have this uphill section to make sure that there is no way that any hot ashes can work their way back into the bellows. The last piece that I need to add to the fire pot is the hinge for the ash dump, and that's where these little guys come in. I bolt 3 of them together. 2 of them get mounted to the fire pot, and 1 goes to the arm of the ash dump. This square plate is the cap that seals off the bottom of the ash dump, and the arm that gets connected to this plate is mounted to the underside. So I have to make sure that the bottom edge of the hinge plate lines up perfectly with the bottom edge of this cap. So here are the finished fire pots ready to go into the forges. So here's the upgraded version of the rivet forge that I built last year. The parts are the same, the bellows is exactly the same size, and the fire pot is built exactly the same way. I just have the parts reconfigured a little bit differently. I was able to build it on a larger frame, which makes it a lot more stable to roll around, because we do have to roll these in and out of the building when we're done using them for the day. And it also made it a lot easier to put a pump style handle on the bellows, because I really didn't like that foot operated pedal that I had on the first one. Unfortunately, I don't have any footage of me actually assembling the bellows that I've made, but if you understand all the parts and how to go together, the rest of it is just using a sewing machine and a staple gun, so I wasn't too worried about that. Here I have a schematic of how everything is laid out. There are 5 boards that are inside the bellows. There's the top board, which is solid. There's a donut, which is basically just a spacer that controls the fabric that you're using for the bellows. The center board has a one-way valve as well as an exit hole that goes to the forge, and it separates the upper chamber from the lower chamber. Below the center board is another donut, and again that controls the fabric that you're using for the bellows. And the bottom board has a valve that allows the air to enter into the bottom chamber. So this is considered a double lung bellows, because as you compress the lower chamber, it forces air up through the valve located in the center board and starts to fill the upper chamber. Once the upper chamber starts to fill, that valve shuts down, and the only way the air can escape is through the hole on the opposite side of the center board, and that goes to the fire. So if you pump the lower chamber quickly enough, it'll keep the upper chamber filled, and that will produce a consistent flow of air to the fire. This is a mock-up that I made to show how the center board is actually assembled. The black square on the top that looks like it's been cut out of a rubber floor mat is actually the valve, and it is cut out from a rubber floor mat. This is an experiment that I tried this year because I wanted to teach classes on how to build bellows with readily accessible materials, and around here leather is kind of hard to get and it's expensive. So I decided to experiment with the rubber floor mat. It doesn't seal quite as tightly as the leather does, but it does a pretty good job. And it's certainly a cheap and readily accessible material. And I also used a heavy waterproof canvas tarp for the fabric of the bellows. This canvas had a really tight weave and it was treated, so there was absolutely no way that you could push any air through this fabric at all, so it was perfect for the sides of a bellows. On each side of the center board I have a wooden block, and they have a hole drilled in them, and that's for the rod that's going to support the bellows in the forge frame. And the support rod is one solid piece that goes right through the bellows and sticks out both sides. On the side opposite the valves, I have the exit hole for the bellows. I have a block glued in place there, and the large drill hole connects to the drill hole that I have coming into the face of the center board. And that provides the air passage from the upper chamber into the tube that leads to the fire. That wooden block is also how I'm going to be mounting the air pipe to the bellows. I have 4 screws sticking out of the face of the center board, and they act as spacers because when the bellows isn't in use, the upper chamber collapses and sits on the center board. So those screws make sure that the donut doesn't shut down the valve or the exit hole. So when you start pumping the bellows, there's some room there for the valve to open and start filling the upper chamber. If you didn't have that air gap, the weight of the wood from the upper chamber would be enough to seal the valve shut and prevent it from operating. So that's basically it. The bottom board is just a solid plywood sheet with the valve set in. There's nothing else that you need because when the bellows is at rest, the bottom chamber is fully extended. There's nothing that could prevent the valve from operating. So to assemble the bellows, you just get all the separate boards ready, and then you sew up a canvas sleeve that these boards fit into, and then you just slide them in place and staple the fabric to the individual boards. The forge itself is basically just an angle iron frame that's set on some casters so we can roll it around. Everything's bolted together, so if we need to make any modifications or want to dismantle these forges, we can just do that very easily. When I filmed the firepot video, I didn't include the grate that I was using, but it's just a simple 4-bar grate, and there's a couple of tabs that are welded to the bottom. These jam into the side of the down tube, so it provides enough resistance to keep the thing locked in position, but if it ever does burn through or you want to change the design, you can pry it out and just reinsert it when you're done. Here you can see how the bellows fits into the frame. Again, you can build this any way that you want. I just have the frame built out of standard spruce 2x4s, but you can use whatever you want. The important thing, regardless of how you set this up, is that the bellows gets locked into whatever forge basin you're using, because there has to be a solid connection between the bellows and the forge. These bellows are small. I wouldn't build bellows any smaller than this for, an average forge. So you can't have any air leakage. So if you have sloppy connections between the forge and the bellows, you're going to lose all of the air pressure that you have in those bellows. They're not a large set of bellows that, are supplying 2.5 times the amount of air that you need. So if you have a loose fit somewhere, you're not going to worry about it too much. You need to get all of the air that these bellows supply to have a good size fire. So they're nice and compact, but you do have to make sure that you get all the air from the bellows to the forge. Here I have a detail of how the firepot is actually mounted into the forge. Again, it has to be a solid connection. With a hand crank blower or something like that, the firepot really doesn't move, so it can be just sitting in the fire pan and it's fine. But because you're cranking on this bellows and there's a bit of movement, if the firepot moves, you're going to break the connection between the forge and the bellows, and that's going to cause air leaks and reduce your efficiency. So everything has to be locked down. As you can see, I'm just using a couple of clips to hold the firepot down, and this is just for maintenance. If we decided to do any changes to this firepot, it's just a matter of removing these 2 clips and pulling the firepot out of the base. Here you can see the pipe going from the fire pot to the bellows. The flange that connects the fire pot to the air tube going to the bellows has a bolted connection, so it's very solid, and it's essentially one piece now from the fire pot over to the bellows. and at the bellows I have the air tube securely screwed in place. So at this point, everything from the bellows over to the fire pod is all tied together into one solid unit. The support rod for the bellows is resting on a couple of notches that I have cut into the uprights for the stand. This gives me some room to adjust the bellows back and forth a little to make sure that I have a good tight fit between the bellows and the rest of the air assembly going to the forge. The one thing that I don't have here is the cover plate that's going to slide over this round bar and lock it in position to the uprights. Again, this is to make sure that it doesn't move and doesn't break any of the connections. The pump handle for the bellows goes to a lifting arm which is located underneath the bellows, and that pushes up on the lower chamber to fill the upper chamber. The connecting rod from the pump handle to the lift arm has a fixed link at the bottom and a swivel link at the top so that you can move the pump handle wherever is comfortable for you, and it still provides a good connection down to the lift handle. The lift handle is part of a double arm system that provides a parallel motion to the bracket that is secured to the bottom board of the bellows. So as you pump the bellows, that bracket is being lifted in a straight line up and down. That's how these circular bellows can get around the hinge mechanism that's usually found on a standard bellows. Hi, I'm Dennis, and thanks for watching. If you have any questions, you can contact me by using the email address that I have shown here. If you like the channel and the work that I'm doing, please consider becoming a patron. Every dollar you contribute will bring me one step closer to being able to produce videos full-time.